Welcome back to my channel. I know it's been a long time since I uploaded a video, so without any further ado, let's start this problem. uh, it's a combinatorics problem. It states that let an denote the number of ways of seating n married couples around a circle such that, so this is the condition 1 here, such that the women and men are seated alternately, and no husband sits next to his wife, right? So these are the two conditions we have to follow here, condition number 1 and condition number 2, and we have to find a5 means for 5 married couples, right? So let me give you an example of a case where it follows. So let's see, h1 w3 h2 w1 h3 w5 h4 W2 H5 W3, right? So this is the case where the or both the condition 1 and 2 are being followed. So like these we have to count these, how many number of cases we have for n is equals to 5, right? So let's just start the problem. Sorry for the vehicle, right? Sorry for the noise. Right, so let us get down to solving this problem. So first of all, for n married couples, we know that there will be n men, right? There will be n men. So first we have to arrange these men in a circle. And the number of ways of doing that is quite simple. We all know n minus 1 factorial, right? Because circular permutation, right? This is basic circular permutation. So n minus 1 factorial ways to arrange the men, right? So let's say we arrange them, right? Now when we have arranged them, we can assume spaces between them, right? So let's say the space between m1 and m2, let's say it is s1, m2 and m3, say it is s2, right? And between mn and m1 it will be msn, right? So we can say that the space between mi and mi plus 1 is si, right? Obviously for I, right, 1, and for n we have to already specially sn, right? You can assume that n plus 1, uh, what you say, o is again counted as m1 or some logic like that, but that is not right, the issue. So like you can say the si, the spaces, right? So we know that now a woman, let's say the wife of mi b wi, right? Wi, if we say, so wi, suppose I is equals to 1, right? For I is equals to 1, it cannot sit in two places. Which two places? This one, right? That is adjacent to m1, his husband, her husband, and the second is this sn, right? This is also adjacent to her husband, like, and right, if we say I is equals to 2, this means wife 2. So wife 2 cannot sit adjacent to m2, right? So that means s2 obviously, and s1, right? So every wife wi has n minus 2 choices, right? We all know s1, s1, s2, sn spaces for the wives. These are n spaces, right? N total spaces, right? N total spaces, and from these n spaces we have to subtract 2 spaces for everyone, right? These spaces are difference, right? What I have written here, choices, right? So let's see what has to be done next now. So what if we talk about first the total cases? What would be the total cases for the uh, arrangement of the wives without any restrictions? So it would be without the restriction of being not able to sit with the husband, right? So it would be like s1. Now you cannot apply another circular permutation here, because now uh, this has nothing to do with the rotation, because the s1 is now being specified as the space between m1 and m2. So s1, s2, these are like a normal, uh, this has to be handled like normal permutations, right? So there are n women's, and we have to first select n women's, so ncn, that is one, right? And to arrange those women, the ways are n factorial, we all know, right? Right, we all know that, and factorial ways to arrange them, right? Now let us talk about, like we are using the bijection method here, right? That is favorable is equals to total minus unfavorable, right? It is quite common technique to use here, right? So total, we have figured it out, right? And factorial, right? After the arrangement of men, right? We are not considering the arrangement of men here, because it is uh, 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 what do I say, not affecting our condition, right? So unfavorable is we have to now count the unfavorable ones, right? So what do we say? Yes, now let's consider about the unfavorable cases. What are the unfavorable cases? So let us define a term, forbidden spots, right? What are the forbidden spots? So consider w1, right? Wife 1. So for wife 1, the forbidden spots are s1 and sn, right? For w2, wife 2, forbidden spots are s2 and s1. w3, s2 and s3. wn, sn and sn minus 1, right? So there are two forbidden spots for each women. Now we know that a woman can only be on any one of the forbidden spots for the unfavorable cases, right? So like if we say uh, uh, w1 chooses s1, s1, then there will be two cases for there will be only be one place for w2, that is s2, to be forbidden, right? If we choose sn, then there would be two places for w2, the forbidden spots, right? So uh, wife I and wife I plus 1, they share a common forbidden spot, right? But only one of them gets to sit there for the unfavorable case, obviously, right? But so how do we deal with it? right? Let us create a hypothetical polygon, right? Let us create a hypothetical polygon, or regular polygon obviously, with two n vertices. Let's say the first vertices is w1 w1 women 1 sitting as s1, right? Let's create the next vertices as w2 sitting on s1, next as w2 sitting on s2, then w3 sitting on s2, then w3 sitting on s3. Likewise, there would be wn sitting on sn minus 1, right? This is minor mistake here. Sn minus 1, then wn sitting on sn, and then w1 sitting on sn. These are the cases, right? Now, as we know that only that w1 can either be on s1 or w1 can either be on sn, right? So, right? So, suppose I of the women sit on the forbidden spots, right? I women sit on the forbidden spot, and the remaining women, that means n minus I women, they sit without restriction, without any restriction. Let us not count them without any restriction on the remaining places, right? So, what my objective is here to use phi, principle of inclusion and exclusion, for the women, right? So let us suppose that I of the women, they are sitting on the forbidden spots. So we have to select I of the cases from this circle, right? All the cases of the forbidden spots, all the arrangements, all the possibilities are present there in this circle, right? We have to select I of them, uh, for I of the women, right? But we can't select, like if we just did 2NCI, then this will not result in the favorable case, because it means that we can also select W1SN and W1S1 simultaneously, but W1 cannot be at both the places W1 as S1 and SN. So this contradicts our case we have taken. So now we have to use another formula, uh, to select I vertices out of n where no two are consecutive, right? Consecutive, right? How will this help us, right? If we select w1 s1, then automatically wn sn w and sn would not be selected, because, and also w1 s1 will not be selected because they are adjacent. And how this helps us? Because it satisfies our condition that no women can be at two different spots. What are our conditions? No women, you can say y, whatever, can be at two different spaces at the same time, and second condition is no no two women can occupy the same space, and this non-consecutive logic, it satisfies both these conditions, right? Because as if w1 sn is selected, the other sitting in sn is already rejected, and the other position of w1, that is s1, is already rejected. So this only caseless remains. So this satisfies our condition, right? Now, to select I vertices out of n where no two are consecutive, so we can just apply the direct formula here, right? And that is wait, n by I, n minus I minus 1, I minus 1, right? I will provide you the link for the proof of this video, right? You can also search it. It's from Maths Merizing, right? You can find it. That is pretty easy. I think the title would be something like non-consecutive selections, circular selections, right? So this direct formula here, I can also provide you the link in the description for that video, right? So this is the formula of I vertices of the ways of choosing I vertices from n such that no two are consecutive, right? You can prove it, you can, like, by yourself, by the gap and, right, gap method, right? It's not that uh, much of a challenge to solve for it, right? But we have 2n vertices, so let's say it is 2ni and 2n minus I minus 1, I minus 1, right? Also if we see that if we divide and multiply by, right, if we just do like this, right, so this will this forms the the relation we have, this relation, right? So this relation, by simplifying it, we can just get 2n by 2n minus I, 2n by 2n minus I, and 2n minus I in I, right? Now the principle of inclusion exclusion, if we say, so uh, so it would be something like k minus 1, k n, and this whole argument in term of k, and the remaining, right? So k women are to be seated in the forbidden spots, so we have made it up for them. Now for the remaining n minus k, they are to be seated without restrictions, right? So these are the unfavorable cases. These are the unfavorable cases here. Now what about total cases? We all already know what is the total case. Total cases were just n factorial, right? N factorial. Now these are the unfavorable, which we calculated by the principle of inclusion exclusion, right? Now using the bijection principle, unfavorable, total, यहाँ पर favorable, right? So what will be favorable cases? N factorial minus I think you got the logic of why I'm using this, right? Right? Because we like used to do that. N A minus N plus N A plus B plus, right? The summation minus N B C D plus N A B C D E, like that it goes for the inclusion exclusion thing, right? So for that we have the alternating signs, starts with a positive always, right? K1 and minus K, right? This gives us n minus K, right? So if we see, if we look closely at this, wait a minute, right? So if we just move this one, right? If we just do this, and if we see, if we apply, if we use uh, k is equals to 0 here, right? If we use k is equals to 0, that would give us 2n by 2n minus 0, 2n minus 0 0 and n factorial. This results into 1, this results into 1, and this results into 1, and this remains n factorial. So this is just the summation when k is equals to 0, right? So what we can do is just that, copy, and I know this does not help, but it gives a pretty, you know, good expression you can use, right? This is and minus k, obviously, right? So this is the final thing. Now we have to also consider the men arrangement which we skipped earlier, right? The men. So the men were in the circular permutation of n minus 1. So we just so this gives us the final result of wait a minute, right? Right, this gives us the result, right? But so a5 is, if you put 4 factorial here and we just solve for it, right? uh, right, and this a5 turns out to be 312. That is the answer to this problem. Now what is different in uh, the answer could also be 3120, right? Which is the answer you will find on the internet if you search for this problem, which gives a false idea that our answer is wrong. But this answer, it comes when the seats the seats are already numbered for the men, right? So if we solve for it, then an extra factor of 2n comes into play. But the problem, it was not given that the seats are distinct. It's just said around the circle, so we do not claim the seats to be different, and this gives us our answer as 312. This is the answer to this problem, right? Thanks for watching. right? This is a pretty advanced problem. It won't probably come uh, in mains. Maybe some part of it could come like the thing, this formula you have to remember. I would provide the link for the uh, derivation of this formula in the description. uh, uh, right, so like I okay, thanks. I hope you